Hi, today we're going to be learning about the gradients of linear graphs. We're going to start off by doing an investigation where we're going to be looking for patterns in a number of different lines. What we're going to do is you're going to draw a number of different graphs all on the same set of axes, and then once we've drawn all the graphs, we're going to look for patterns. Okay, so I'm going to give you 1 minute for each graph that you're going to draw. So here's the first one you're going to draw, y equals 2x minus 2. You have 1 minute to draw this. Okay, so let's take a look at that graph. You should have found that your y-intercept is -2, so that's over there. Your x-intercept, you should have found was 1 by making y equal to 0 and solving for x, so that's over there. So if you join that up, you should get a line that looks like that with the equation y equals 2x minus 2. Right, let's have a look at our next graph. Now remember, you're going to draw this on the same set of axes. Okay, so I'm going to give you 1 minute to draw this graph as well. Okay, so for this graph, you should have had a y-intercept of 6, an x-intercept of 2, and when you join it up, your graph should look like this, and it has the equation y equals negative 3x plus 6. Right, here's the next one. You have a minute again. Okay, so for this one, your y-intercept should be negative 3, your x-intercept should be 6, and your graph should look like this, with the equation y equals a half x minus 3. Right, here's the next one. You have a minute again. Okay, so for this one, you should have had a y-intercept of -1, an x-intercept of -3, and then your graph should look like this, with the equation y equals -1/3 x minus 1. Right, here's the next one. You've got 1 minute again. Okay, so for this one, your y-intercept is 1, your x-intercept is -2, and your graph should look like this, with the equation y equals 1/2 x plus 1. Right, here's the next one. You have 1 minute again. The y-intercept for this graph should be 2. The x-intercept for this graph should be 6, and your graph should look like this, with the equation y equals -1/3 x plus 2. Right, here's the next one. Okay, you've got 1 minute again. Okay, so this graph's y-intercept is -9, its x-intercept is -3, and the graph should look like this, with the equation y equals -3x minus 9. Right, then the last graph that we're going to be drawing on these axes is this one over here. You have 1 minute for this one as well. Okay, so this one should have a y-intercept of 4, an x-intercept of -2, and the graph should look like this with the equation y equals 2x plus 4. Okay, now the next thing we're going to do is look for patterns. So what I want you to do now is I want you to look for pairs of lines that we've drawn over here that seem parallel, and I want you to highlight them with the same color. I'm going to give you 1 minute to do that as well. Okay, so let's see what you should have found. So first, you should find that these two lines over here are parallel, and you should have highlighted them with the same color. These two are also parallel to each other. Then these two are also parallel, and these two are parallel. Okay, now what I want you to do is I want you to look for patterns in the equations of the graphs. Consider how the numbers in the equations relate to the characteristics of the graphs that you've drawn. I'm going to give you 1 minute to look for any patterns that you can find. Okay, so let's go through a few things that you might have noticed. First of all, I hope that you noticed that when lines are parallel to each other, there's something that they have in common in their equations. So first of all, if you look over here, these two lines are parallel. They both have a 2 in front of their x. Okay, so it's y equals 2x plus 4 and y equals 2x minus 2. That 2 is common. Then if you look at these over here, they're also parallel, and the number in front of x is a half for both of them. If you look at these ones over here, they're also parallel, and the number in front of x is -1/3 for both of them. And then if you look at these ones over here, they're also parallel, and they both have -3 in front of x. So when you have lines that are parallel to each other, when the equation is written in standard form, then the number in front of x, which is the m value, is going to be the same. Then I also want you to notice that the blue lines and the purple lines are both increasing graphs. They are going up as we go from left to right. They both have positive m values. These values over here in front of x are positive, but these ones over here have negative, and they are pointing downwards. They are decreasing. Okay, so when you have graphs that are going up as you move from left to right, they're increasing, then the number in front of x, when it's written in standard form, is going to be positive. When it is going down or decreasing from left to right, then the number in front of x, the m value, is going to be negative. Also, if you look at these ones over here and these ones, they are steep and they've got higher values. If you look at the actual number, the 3 and the 2, they're higher. But if you've got ones that have a more gradual slope, then they're going to be fractions like this, a half or a third. Okay, so those are some patterns that we can find when we're looking at the slopes of our graphs. Okay, now let's go and have a look at what the gradient of a graph is. This is the m value in our equation, y equals mx plus c. The gradient is the slope or inclination of a straight line graph. It basically tells us the direction that the graph is going. Okay, we can work out the gradient using rise over run. If you take 2 points on the graph, you can work out rise over run by saying rise is the vertical distance between the points and run is the horizontal distance between the points. Okay, so we have rise over run. If you take the rise and you put it over run, that will tell us what the gradient is. Another way that we can work out the gradient is using the formula delta y over delta x, which is change in y over change in x. So it's how much the y values change from one point to the other. Again, it's the same as the rise, okay? That is delta y, it's change in y. And then change in x is how much you change the x value from the one point to the other point as well. Again, it's the same as the run. So delta y over delta x is the change in y over change in x. We can also use the formula y2 minus y1 over x2 minus x1 by using the coordinates of the points. If this point is point 2 and this point is point 1, then the x and y values of point 2 are x2 and y2, and the x and y values of point 1 are x1 and y1. So we can work out the rise or the change in y by saying y2 minus y1. That tells us the difference between those 2 points, the vertical difference between the 2 points. And then we can use x2 minus x1 to find out the horizontal difference between those 2 points. Okay, which is change in x. Then the gradient is also the m value in the equation if it's written in standard form, y equals mx plus c. So this number over here is our gradient. Just like when we were doing our investigation, we found that that number in front of x, that is the number that we were looking at when we were finding if lines were parallel, or if they were going up, or if they were going down, or if they were steep, or if they had a gradual slope. The m value is the gradient, and that tells us all of that information. Okay, so now let's go and have a look at the different kinds of m values that we can get and what it can tell us. First of all, if your m value is greater than 0, so it's positive, then the line will slope upwards. So it could look like that, or you could have a graph looking like that, or looking like that. Any line that is sloping upwards as you move from left to right has a positive gradient. The m value is going to be greater than 0. If the m value is less than 0, so it's negative, then the line will slope downwards. It'll look something like this, or that, or that. Those are all examples of lines that have a negative gradient. So they're sloping down. As you go from left to right, the line slopes downwards. Then, if your line has a gradient equal to 1, so if m is equal to 1, then the line will form a 45-degree angle with the x-axis. So this angle over here will be 45 degrees. And if your line has a gradient of -1, then it will also form a 45-degree angle, but it will be below the x-axis, like that, or 45 degrees on this side over there. Please note that this is only true if the x and y axes are scaled equally. Then, if your line has a gradient greater than 1, the line will have a steep upward slope. If it has a gradient that is less than -1, then it will have a steep downward slope. Then, if your line has a gradient between 0 and 1, so it's a fraction less than 1, then the line will have a gradual upward slope. And if your line has a gradient between -1 and 0, so it's a negative fraction, but it's between -1 and 0, then it will have a gradual downward slope. Also, if you have two lines that are parallel to each other, then their gradients will be equal to each other. So if line 1 is parallel to line 2, then the gradient of line 1 will be the same as the gradient of line 2. Okay, now let's go and have a look at an example where we're actually going to work out what the gradient of a line is. So in this example, we've been given a graph, and you've been given 2 points on this graph, and we need to find out what the gradient of this graph is. So let's go and have a look at how we would do this. Right, so over here I've drawn the graph. So you can see I've got the point -4, that's our y-intercept, and I've got the point 6, that's our x-intercept. Now what we're actually going to do over here is it'll be easier to do this if we can see the coordinates of these points, not just the 6 and the -4. I want this written as a set of coordinates. So this point over here is the point 6, 0, and this point is the point 0, -4. Okay, so the x-intercept is where y is 0, and the y-intercept is where x is 0. Okay, so those are the coordinates of the 2 points that I've got. Now I'm going to go and work out the gradient using the formula y2 minus y1 over x2 minus x1. So over here, y2 and y1 are both going to come from the same point, and x2 and x1 are both going to come from the same point. Okay, so I'm going to choose which point I want to make point 2 and which point I want to make point 1. So I'm going to make this point over here point 2 and this point 1. Okay, so what I'm going to do now is I'm going to take the y value from point 2, and that's -4. So I have -4 minus the y value from point 1 is 0. And that goes over the x value from point 2 is 0 minus the x value from point 1 is 6. And now I'm going to go and simplify this. So over here I've got -4 minus 0 is -4 over 0 minus 6 is -6. So now I've got a negative divided by negative, that's positive. And then 4 over 6 I can simplify. 2 goes into both of those. 2 goes into 4 twice, and 2 goes into 6 3 times. So my gradient for this graph is positive 2 over 3. Okay, so now I'm going to give you a couple like that you're going to do for yourself. You're going to practice using the equation y2 minus y1 over x2 minus x1, using the points that you're given on a graph to find the gradient of that line. Okay, so here's the first one you're going to do. I'm going to give you 1 minute to find the gradient of this line. Okay, so let's go through how you would do this question. Right, so here's my graph that you were given. You've got the point -5, 6 over here, and you've been told that it's going through the origin. Now the coordinates of the origin are 0, 0. Okay, so these are going to be the 2 points I'm going to use. I'm going to say that this one over here is going to be my point 2, and this is going to be the point 1. Whenever your graph goes through the origin, I always recommend using the origin as point 1 because it's going to be easier to work out. Okay, so now I have my gradient m equals y2 minus y1 over x2 minus x1. Okay, so in point 2, my y value is 6 minus my y value of point 1, which is 0, over my x value of point 2 is -5, minus my x value of point 1, which is 0. Okay, so now this gives me 6 over -5. I don't have to worry about these minus zeros because they're not going to do anything. Okay, so I have 6 over -5. That gives me -6 over 5. Okay, right, let's go on to the next one. I'm going to give you 1 minute to find the gradient of this line as well. Okay, so let's go through that question and see what you should have got. Right, so over here, I've got my graph, and I've already started off by writing down my formula that I'm going to be using, y2 minus y1 over x2 minus x1. Now, in this one over here, you've already been given both points with their coordinates. You don't have to write down what their coordinates are. I'm just going to choose which point I'm going to make point 1 and which one I'm going to make point 2. So I will make this point 2 and this point 1. Okay, right, so now let's go over here and fill them in. So my y value of point 2 is negative 1 minus the y value of point 1, which is 3, over the x value of point 2 is 1 minus the x value of point 1, which is also 3. Okay, so now let's go and simplify this. So I've got negative 1 minus 3 at the top. That gives me negative 4 over 1 minus 3, which is negative 2. So I've got a negative divided by negative. That gives me positive. 4 over 2 is 2. So you should have got a gradient of 2 for that graph. Right, let's go on to question C. I'm going to give you 1 minute to find the gradient of this line as well. Okay, so let's take a look at what you should have got. So for this graph, I've been told the y-intercept is 5, and I've been given this point over here, which is the coordinates 3, 5. So for my y-intercept, if I write it with its full coordinates, it's going to be 0, 5. Okay, the x value is 0 and the y value is 5. Right, so I'm going to make this my point 2 and this my point 1. Okay, so that's going to be y2 is 5 minus y1 is also 5 over my x2 is going to be 0 minus x1, which is 3. Okay, so that gives me 5 minus 5 is 0 over 0 minus 3 is negative 3. Now 0 divided by anything stays 0. So my gradient for this line over here is going to be 0. Right, let's have a look at our next one. Question D. I'm going to give you 1 minute to find the gradient of this line as well. Okay, so let's go through that and see what you should have got. Right, so over here, again, I've written down my formula already. In my graph, I've been given the x-intercept, which is -3. So the coordinates of that point will be -3, 0. And I'm going to make this point 1 and this point 2. Okay, so over here, I'm going to have y2 is 2 minus y1, which is 0, over, then x2 is -3 over there. And then minus x1 is also -3. Now I have to put this in brackets. I have a negative minus a negative. Okay. And then we're going to go and simplify this. So 2 minus 0 is 2. Then I've got -3 minus -3 is plus 3. And that gives me 0. So now I've got 2 over 0. But now I've got a problem because I can't divide by 0. It's not the same as the previous one. 0 divided by anything stays 0. And that's fine. But this one over here, I'm dividing by the 0. And you can't do that. It is undefined. So here I say, therefore, the gradient is undefined. Because we cannot divide by 0. So when you've got a vertical line like this, which is parallel to the y-axis, then the gradient will be undefined. Okay, now let's go on to our next example. In this example, we're being asked to determine the gradient of this graph, and we've been given the equation of the graph. We're not being given the actual graph itself and points on the graph. Now we've been given the equation of the graph. So let's have a look at how we would find out the gradient of this graph. Okay, so now the first thing you need to remember, when you're going to find the gradient of a graph from the equation, is you need the equation to be in standard form, because the gradient is the m value in the equation. Now this equation over here has not been given in standard form, so we need to change it so that it is in standard form. Remember, standard form is y equals mx plus c. So we need to get this equation to look like that, where we've got y on the left without a number or anything, it's just y equal to something x plus a constant. Okay, so the first thing I'm going to do is I need to get rid of the 3x on the side. Okay, so what I'm going to do is I'm going to subtract 3x to get rid of it, so that means I'm going to subtract 3x on the other side as well. So I've got -2y equals, now I want the x term to be before the constant, so I'm going to write the -3x over here before I write the 4. And then it's plus 4, that 4 is positive, so it's plus 4. Okay, so far, I've now got the terms in the correct places. I've got my y on the left, then I've got my x term, and then I've got my constant. But it still isn't in this form. I still need it to be just y. At the moment, I've got -2y, which isn't what I need. I need just y. So to get the y as just y, I need to get rid of that -2 by dividing by -2. So I need to now divide every single term in the equation by -2. So I'm going to divide this by -2, that gives me y, equals. I divide this by -2, so I've got a negative divided by negative is positive, and 3 divided by 2 is 3 over 2. X, and then a positive 4 divided by -2 is -2. So now I've got my equation in the form y equals mx plus c. So this is standard form. Now what I can do is I can say my gradient is the m value in the equation, which means if I look at my equation over here, this is the m value, which means that my gradient is going to be 3 over 2. Okay, so that's how we find the gradient from the equation of a line. Right, now I'm going to give you a few that you're going to practice for yourself. Here's the first one that you're going to do. I'm going to give you 30 seconds to find the gradient of this line. Okay, so let's go through that and see what you should have got. Right, so the first thing you do is you check if your equation is written in standard form. In this case, it's already been written in standard form. I've got y on the left equal to something x, and then I've got a constant. So it has already been written in the form y equals mx plus c. So now my gradient is going to be the coefficient of x. Remember, it's mx. My gradient is the m. So in this case, you can't see a number in front of the x, but that means it's a 1. So our gradient for this graph over here is going to be 1. So m is equal to 1. So that's what you should have got for question A. Right, let's go on to question B. You have 3 seconds to find the gradient for this equation as well. Okay, so let's go through that question. Right, so over here, in this case, it has not been written in standard form. So I need to change the equation so that it's in standard form by first moving my terms so that they're in the correct order. So I need the y on the left equal to, I need to get rid of the 2x on this side by subtracting on both sides, and I need it to be first before the constant. So it's going to be y equals negative 2x, and then I've got my minus 3. Now, if you look over here, the y is already just y. So I don't need to do anything else. I don't need to divide by anything because it's already now in the form y equals mx plus c. So now I can get my gradient using the coefficient of x. So that's m equals negative 2. Right, let's go on to question C. Okay, you have 3 seconds to find the gradient of the graph for this equation as well. Okay, so let's go through that question. Right, so this equation has not been written in standard form, so I need to rearrange and then see if I need to do anything else. So first I'm going to rearrange, so I have my y term on the left, so that's negative 3y, so I'm going to be subtracting x on both sides, so it's equal to negative x, and then plus 9. Then I still need to get the y on its own, so I'm going to divide every term in this equation by negative 3. So I've got y equals negative x divided by negative 3. I've got negative divided by negative is positive. Then this is 1x, so it's 1 divided by 3, that's 1 over 3, 1/3 x. And then positive 9 divided by negative 3 is minus 3. So that's what you should have got for the equation. Y equals 1/3 x minus 3. Now it is in standard form, so I can get my gradient from the equation and say, therefore, m is equal to the coefficient of x, which is 1/3. So that is what your gradient is for that equation. Okay, let's go on to the next one. Okay, so you have 30 seconds for this one as well. Okay, so let's go through that question. Now, in this equation, it actually is written in the form y equals mx plus c, where you've got y, and then your c value is negative 2. It's just the mx is 0 because the gradient is making that term cancel out, which means that the m must be 0. So in this case over here, because there's no mx term, it means that our gradient is 0. This is one of those graphs that's going to be horizontal, parallel to the x-axis. So the gradient is 0. Okay, so in one like this where you've got y equal to a number, your gradient is going to be 0 because that mx term is 0. Okay, so that means your gradient must be 0. Right? Let's go on to the last one for today. You have 3 seconds for this one as well. Okay, so let's go through that question. So in this one, I've got x equals 4. Now, it is not written in the form y equals mx plus c, but I also can't get it to that form because there's no y in the equation. So I can't get a y on the left-hand side of the equation equal to an x term plus a constant. I only have x and a constant. So this is one of those graphs where it's going to be parallel to the y-axis, cutting through the x-axis, and it's vertical. So I can't find a gradient of this graph. When you are not able to get the graph to standard form because there's no y in the equation, it means that your gradient is undefined. So that's what you should have got for question E, that the gradient is undefined. So whenever you have an equation x equal to a number and there's no y in the equation, then the gradient is going to be undefined. And that's how we find the gradients of linear graphs. Now that we've learned the concepts in this lesson, it's important to practice, practice, practice. If you haven't already got the worksheet that goes with this video, you can find it by clicking on the link in the description below. The worksheet comes with an extra exercise full of questions for you to work on to master the concepts covered in this lesson. If you found this video helpful, please hit the like button so that others can benefit from it too. Also, be sure to subscribe so that you can easily find my other lessons, and hit the bell so that you will get notified about lessons as I upload them.